This is problem 35 from the electric field. Below are 6 configurations of two electric charges located at x equal to 2a and y equal to 0, and x equal to 0 and y equal to 2a. You can tell by looking at the diagrams that the origin cannot be at the center of the diagram. And if these are the locations of the two charges, the origin must be here. So this charge would be at x equal to 2a and y equal to 0, and this charge would be at x equal to 0 and y equal to 2a. So the origin is here. And if you're looking in your book, you should be able to see that these lines are solid and these lines are dashed. So that shows you that this is the x-axis and this is the y-axis. It doesn't always print out, or in the video, I don't know if you'll be able to tell, but that also helps you figure out where the origin is. Okay, so we want to rank these configurations on the magnitude of the electric field at the origin. So where I put my red dot. So that's not at the center of the diagram because we carefully read this and figured out that the origin is here. Okay, now I have an advantage in this problem because all of the charges are 2 blocks away from the origin, which means that when I look at my equation for the electric field, the r squared is going to be the same for all of the charges. So what is changing is the direction, and also q is changing. And so if I have a 2q, the magnitude of the electric field from a 2q charge should be twice what it is for a charge q. Okay, so I'm going to say if we're 2 blocks away and the charge is q, the electric field has a length of 1 block, and that points away from positive charges, so away and away, 1 block because the charge is q. If the charge is 2q, that should be twice as large based on our equation here, so that should be 2 blocks. And this would be 1 block. And a negative q charge has the electric field pointing towards the charge, so this would be 1 block pointing towards the charge, and this is 1 block pointing away from the charge. This is 1 block pointing away. This is a negative charge, so the electric field points towards, and it's 1 block because the magnitude of the charge is q. This is plus 2q, so that points 2 blocks down. This is plus 2q, so that points 2 blocks away. This is plus 2q, so that points 2 blocks down. This is minus 2q, so that points 2 blocks towards. I don't think I got the scale quite right there. We'll make that one a little longer. Okay, so now to find the net electric field, I have to add the charges to I have to add the individual electric fields together. So adding these two charges together, if I slide this vector over and place them tip to tail, this is my resultant vector. So 1 over and 1 down. This is 1 over and 2 down. This is 1 over and 1 up. This is 1 over and 1 down. This one was kind of hard to do because it went off the diagram. But this is 2 blocks over, 2 blocks down. So that's like this. And this is 2 blocks over and 2 blocks down also. So if we're looking at the magnitude of the electric field, C, A, and D have the same magnitude, and those are the smallest because those were always 1 block in the horizontal direction and 1 block in the vertical direction. So A, D, and C are equal to each other, so A is equal to D. Oh, generally, it doesn't really matter for homework, but if you have some that are equal to each other, it's nice if you can put it in alphabetical order. It didn't happen here. That's okay. But alphabetical order would be preferred, but not necessary. Okay, E and F are equal to each other because they both go 2 blocks down and then 2 blocks either to the left or to the right. So E and F are equal. And then B, it's not equal to E, and because it goes 2 blocks down and only 1 block over, and it's greater than A. So B goes in the middle there. In part B, we want to rank these configurations on the basis of the angle the electric field at the origin makes with the x-axis. Measure these angles counterclockwise from the x-axis. That is how we usually measure angles. So from the x-axis to the angle, that would be like this for A, so that's somewhere between 180 and 270. For B, again, somewhere between 180 and 270. For C, somewhere between 90 and 180. For D, somewhere between 270 and 360. For E, somewhere between 180 and 270. And for F, somewhere between 270 and 360. Now, we are going from largest to smallest here. A lot of times people end up getting this backwards. Because if we start here, I guess C is the first one we encounter, so they want to put it here, but it's the smallest angle. So C actually goes here. Okay, so if you get it wrong, and if you have them going from smallest to largest in your homework, I wouldn't take points off, but what I would do is circle from largest to smallest and then draw something like this underneath your ranking, like right up here. So this just shows you that your ranking was correct, just going the wrong way around. So if it's something where you're measuring angles, pay attention to this. If it's wrong, this is how I mark your homework. If it's just wrong because you went in the wrong order there. Okay, so then after C, that was the only one in the second quadrant. So we have A, B, and E in the third quadrant. A and E are both, if you look at this angle here, that angle would be 45 degrees because you're going 1 block over, 1 block down, or 2 blocks over, 2 blocks down. So A and E would be equal to each other. And for B, you're going 2 down, but only 1 over. So this angle is greater than 45 degrees, which means A and E are smaller angles than B. Okay, and then we have F, and we have D. D is going 1 block down and 1 block over. E is going 2 blocks down and 2 blocks over. So these angles here, measured with a negative y-axis, are both 45 degrees. So D and F are equal to each other. And that concludes problem 35.